Okay, test number 3. Test number 3, I'm taking a test which is a functional test, and the very simple functional test, I'm going to explain it. Okay, it's an example of any functional test. Okay, the test I'm talking about is something called POR, power on reset. What is power on reset? Power on reset means that after the device is powered on, it is going to wait 16 clock cycles before it comes out of the reset stage. Okay, before it comes out of the reset stage, it is going to wait 16 clock cycles. Okay, so what are we going to talk about? Our example, I've taken this as the simplest example of a functional test, is we are going to see that we're going to give it 15 clock cycles, know the current, and expect after the 16th clock cycle the current to go up as the device comes out of reset state. Okay, as it comes out of reset state, we'd know, and we would be able to say that the device worked, the part of the device called power on reset is working. Okay, I've used this as the very, very simple example of a functional test, where in the end you may have measured some type of parameter like current. Okay. A very useful example is IPD. Your current in power down mode. Your current in power down mode would be is at least for the generation where I worked on the chips, it was something which would have shown the quality of the silicon, how much leakage you have in the silicon. Okay, it was one of the tests which was focused on for automotive, which at the moment brings me to a different topic. Okay, the different topic is a topic called testing versus verification. Okay, when a device is designed, you have a team that create an environment around the device for verifying the device in software. So we say there's a software programming language called E, which was called Specman, which was used at the time in Intel, and a programming language which I learned, which I learned but never really worked on, was called System Verilog. Okay, and what you're doing is, at the time of the design of the chip, you are creating a stimulus to check that the chip works. So when the chip goes to manufacturing and goes onto a silicon tester, nobody writes the test patterns. The test patterns are inherited from the test patterns are inherited from the people that do the verification. If one goes back to the early 1980s, one can see old test programs where people were still writing the test patterns manually, and you sometimes saw test patterns which were documented. But today no one writes test patterns, it comes out of System Verilog. Okay, this is your basic functional test. Okay, I've used a very simple example of power on reset. To take functional test further, there's something called VOL. VOL and VIL. Okay. For example, this output has a parameter. How much current can it sink? How much current can it source? 3.3 volts. What happens if I give it 2.5 volts? Okay, all these things are parameters which are changed within the tester as the device is characterized. Okay. Some of the concepts here would be this: the way that these two comparators are put. It's called a window comparator. A window comparator means whatever voltage I'm putting over here, I'm calling high. Okay, let me even use the right terminology for this. Okay, this one I call CVH. And CVL. CVH and CVL would be able to if I put 4 volts over here and 0.7 volts over here, and I have 4.1 volts, it's going to respond to me as a high. If I have a CVL as 0.6 volts and suddenly I get 0.5, it's going to respond to me as a low. So this sets up what is considered high and low. Okay. On the drive side, this is the drive side. Okay, I'm going to have something called DVH, DVL. Okay. DVH and DVL will set up the stimulus drive voltages. So I can program what voltage I want to be called high and what voltage I want to be called low. Okay. Okay, these I think this is relatively standard to a chip, to testers. That the DVL, DVL device drive high, drive low, compare low. Okay. I'm now gonna walk you through a functional test of a simple 2-input AND gate. 7400 or something like that. I think that's an AND gate is, I think it's 7408. Many years since I touched that. Okay. In your tester memory, you have a pattern, a test pattern. If I have 0, 0, output is 0. 1, 0, 1, 0, still 0. The only time we have an output of 1 is when both inputs are 1. Okay. So now, in the previous minutes, I tried to start explaining DVH, DVL. DVH and DVL means when I have a 1, I'm going to get 5 volts here. If I had DVH as 4, then my high voltage would be 4 volts out. Okay. DVL. Okay. That determines your voltage. Now, if one goes through a data sheet, one will see that what is the minimum that you can have for which is considered high, what's the minimum, what's the highest value, which is considered low. Okay, these are these parameters here, DVL, DVH. Back in the days of Trillium, the board that would have done this was a board which is called PREF. Okay, these were low speed. These are considered low speed levels. Okay, the levels for your test. Okay, I sync, I source, and VREF in the middle. Okay. Okay. So I explained what DVH, DVL, DVH, DVL. Those would be on the output side, on the drive side. CVH and CVL are on the receive line, on the response logic side, your inputs. And here, for example, you'd say I'm expecting a 4 volts, and I'm expecting my load to be below 1 volt. So if I'm above 4 volts, it'll pass, or if I'm below 1 volt, it will fail. Okay, this is a very simple example of a functional test of a 2-input AND gate. Okay, the response logic will either match or it will fail. Okay, this type of test is either pass or fail. There's no playing around with passing or failing. It is not a parametric test. It's a wiggle pass fail test. Okay. Another parameter which is here is the speed with which you are writing out the data. the speed at which you're writing out the data, how you're setting up your data. I don't want to go into details about what Trillium had modes around by complement, return to zero, non-return to zero. I don't want to go there because it's a 40-year-old test which no one was interested in. Okay, however, everything else which I've described here is still very much true today in testing.